Alright, this is Calculus Notes on section 2.3. This is page 2. So what we want to do is sketch the graph of this piecewise function. We have a lot of stuff going on with this one. This applies for every value except x equals 4. And then we have a particular y value to plug in for x equals 4. We have to determine where the graph is discontinuous and identify the type of discontinuity that occurs here. So, first thing, if I encounter this when I'm graphing, I want to see if I can simplify it for sure. So I'm going to work up here, and with the denominator of x minus 4, I'm thinking that the numerator might be factorable with an x minus 4 factor in that. I'm going to guess that. And if I continue the factoring here, basically this shakes out to be x plus 1 times x minus 4. The x minus 4's cancel, and so when I graph this function, I can simply graph it as the function, the line, x plus 1. Now, what happens when I eliminate a binomial from the denominator? It creates a hole. So we have a hole at x equals positive 4. And I actually want to know where that hole is exactly, so I would like to have the y value. And if you remember, to get the y value of the hole, basically I take the limit of the function as x approaches 4, which is simply, in this case, the practice of plugging in 4 here. So if I plug in 4, I get the 0.5. So there is a hole in this graph at the 0.45, and the graph itself is going to look like this line, except for that hole. So I'm going to plot out here the 0.45. I like to put that in place first so that I don't forget to make the hole. My y-intercept is 1. So I'm just going to continue my graph from there and contain all those values. So that is my graph with my hole right there at 0.45. Okay. Also on the graph, x equals 4. At x equals 4, the y value is equal to 2. So at x equals 4, that's this value here, my y value is equal to 2, which is about right there. What type of discontinuity is this? It is a removable discontinuity. Holes are removable discontinuities because I could rewrite it, the piecewise function, and basically move that point to there. We're not going to do it on this problem. The other thing it was asking is, where is the graph discontinuous? So I would report that it's discontinuous at x equals 4. I don't need the point for the hole. I just need the x value of where it is discontinuous. It's discontinuous because of the hole, but this is where it's located. Okay? And that's really all you need to do on this problem. The next problem is a little more interesting, and it's actually very similar. They want us to sketch a graph of this function, determine whether the graph is discontinuous, identify the type of discontinuity, and then finally redefine or extend the function to make it continuous. So again, when you're looking at a function like that, we need to consider, can we simplify it? I'm expecting a factor of x plus 3 to be able to come out of the numerator. Let's see if that'll work. If that's a 3, this has to be a 1. If that's an x, this needs to be a 2x. And my sign would need to be positive. Just to double check, I got 1x there and I have 6x there to make 7x. I'm good to go. Most of the time it's going to factor and cancel, but every once in a while you'll get one that doesn't. So you should always check. So if I cancel that, I'm going to be left with a graph that looks like the line 2x plus 1. But because I canceled the binomial in the denominator, I actually have a hole at x equals, this time it will be negative 3. Since I'm graphing, I do want to know what that point is. So I take the limit of the function as x approaches negative 3, which involves just simply plugging in negative 3, and I get negative 5. So I have a hole at that location. My graph is linear, slope of 2, intercept of 1. So I'm going to go ahead and start with my hole here, place it on my graph. My line 2x plus 1 has to cross right about there. So I'll just sketch my line with the hole in it. And that's all we were given this time. So let's start answering the questions here. Where is the graph discontinuous? It's discontinuous at x equals -3. Remember, all you need is the x location. The type of discontinuity? It's a removable discontinuity. The discontinuity is caused by the hole, okay, but it's called a removable discontinuity. Finally, it wants us to redefine or extend the function to make it continuous. In order to do this, we will create a piecewise function, and basically you're going to repeat the original function and the original version, not the simplified version. So there's my original function. That applies everywhere except x equals 3. So everywhere except x equals, -3, not 3. And now my task is to fill that hole. So I need to fill the hole. Actually, I want this to be filled in, just like that. So the value I need to fill it in with, the y value, is -5. So I want my function value to equal -5 when x equals -3. Okay, so basically what I did with that step right there, this -5 basically fills the hole right there. And that is all we have for that one.